Good day, everybody, and this is our video on transformations. It's quite a lengthy topic, and there's a lot that you are going to have to take a note of, and there's a lot that you're going to have to remember. Um, but it's actually quite easy and simple. It's going to require you to be able to be good at the multiplication of matrices. So if you're not yet good at the multiplication of matrices, check out our Matrices 1 video. Also, that Matrices 1 video covered the very beginnings of transformations, and that's when we spoke about the translation. And we could see here, just to recap on the translation, a translation is if I had a triangle ABC, where ABC, I have the coordinates of ABC over here, and I was to move this triangle under the translation T. The translation is a vector which represents movement. That means that it'll move X spaces horizontally and Y spaces vertically. And therefore, because of that translation, how do I work it? Is I put all of the points A, B, and C of the object into a matrix here, and then I simply just add the translation to it, and I get the points of the image A prime, B prime, C prime in this matrix over here. So if you need a little refresher on translations, just check out the Matrices 1 video, where we talk a little bit more in detail about translations, and we do a couple exercises and questions. Now, moving on with transformations in this Transformations 2 video. Essentially, what we're going to be dealing with here are many different types of transformations. Now, the first type of transformation that we are dealing with here is the reflection, and there are different types of reflections. So in this first reflection, we are going to be dealing with a reflection in the x-axis. Now, a reflection in the x-axis is given by this transformation. Now, when we talk about reflections, we generally label it M. So you could see here that the reflection in the x-axis is given by a 2 by 2 matrix transformation 1, 0, 0, negative 1, where we call it MX, and MX stands for a reflection in the x-axis. So basically, if you was to take this image, so take for example this image, the triangle ABC is given by these points here, and you need to find the image as a reflection of the x-axis. So you need to know this matrix here, this 2 by 2 matrix transformation. You need to know this by heart, that this represents a reflection in the x-axis. So how do I do this? Is I basically take my reflection, I basically take my points A, B, and C. So how do I do this? Is I basically take my reflection transformation MX, and I write the matrix for that 1, 0, 0, negative 1, and I'm going to multiply that by my matrix of A, B, and C, and that would be A is negative 3, 2, B is 1, 4, and C is negative 1, 1. And that should give me the three points A prime, B prime, C prime of my image, right? Now, in order to do this, we have to do matrix multiplication. So how about you multiply these two matrices? And notice, please, that I put the reflection first, because the amount of columns in this side here needs to be equal to the amount of rows I have on this side here. So see if you could multiply these two matrices and tell me what you get for A prime, B prime, C prime. Now, hopefully, if you remember how to do your matrix multiplication, you'll see, and we'll just do a quick reminder here. I have 1 times -3, which is -3, plus 0 times 2, which is 0, right? 1 times 1, which is 1, plus 0 times 4, which is 0. 1 times -1, which is -1, plus 0 times 1, which is 0, right? Now we'll do the second row here. 0 times -3 is 0, and -1 times 2 is -2. 0 times 1 is 0, and -1 times times 4 is -4. And 0 times -1 is 0, and -1 times 1 gives us -1. If you can't quite remember how to do your matrix multiplication, just check out that Matrices 1 video where we handle the basic operations of matrices and matrix multiplication in a little more detail, right? So we get this here being -3, 1, -1, and then -2, -4, -1. So this here represents A prime, B prime, and C prime. So let's plot A prime, B prime, and C prime and see what it looks like, right? So we have A prime here being -3. So we have -2, -3, and -2. So that should be about here. So this will be my A prime. We have B prime to be 1 on the x-axis, about here, and -4. So that brings us here. So this is my B prime. And then we have C prime to be -1 on the x and -1 on the y. So about here, so, and this will be my C prime. And if we draw, and this is just a crude sketch, we could see that the image is actually a reflection in the x-axis of the object. Yeah, and it's a crude drawing, but you could see that the x-axis here acts as a mirror line for our reflection. Right? So just to recap, we need to know what the matrix, this matrix here for the reflection in the x-axis, we need to know what that matrix is. And when we are multiplying, we put our transformation matrix first, and then we put the object afterwards, right? Now let's check out the second part of reflections, and we are talking about here a reflection in the y-axis, and the reflection of the y-axis is given by my this time, and it is -1, 0, 0, 1. And so similarly for the example, if I was to have a triangle PQR, and you could see here it's very crudely drawn, the triangle PQR. We just drawing sketches for these things just to get an idea of what these things look like. And we have to find the image P prime, Q prime, R prime as a reflection in the y-axis. So I put my transformation my first. So that is -1, 0, 0, 1. And then I multiply that by my P, Q, and R points. This is my object. So P being 2, 3, Q being 4, -1, and R being 1, 0. And hopefully this should give us the P prime, Q prime, and R prime. So please go ahead and see if you could do this matrix multiplication and pause the video, and hopefully you'll get the answer. Right, so hopefully when you did the matrix multiplication, you were able to get p prime to be negative 2, 3, q prime to be negative 4, negative 1, and r prime to be negative 1, 0. Right? Now let's plot these points and see how they look in our little sketch here. So we have p prime to be negative 2 on the x and 3 on the y, which puts it about here, p prime. Right? We have q prime being negative 4 on the x and negative 1 on the y, so that puts it about here, and that is our q prime. And then we have r prime to be negative 1 on the x and 0 on the y, so that puts it about here, r prime. And when we draw our sketch, we see that the image basically looks just like a reflection of the object if we had the y-axis as our mirror line. So just make note that your transformation matrix must come before the object matrix in this multiplication, and you also have to learn this matrix by heart, the matrix of my, which is a reflection in the y-axis. So please give that a write down. Right, so in our third section on reflections, we have here a reflection in the line y is equal to x. So we have here the line y is equal to x. We have an object and parallelogram ABCD. In this case, it's a trapezium. And we have the 2 by 2 matrix. Now, our reflection in the line y is equal to x is given by a 2 by 2 matrix transformation. And that there is our matrix transformation. 1, 0, 1, 1, 0, right? So if we were to have the object being the trapezium ABCD, and it's reflected in the line y is equal to x, we have the transformation, the m of y is equal to x, and we're going to put that first, and that is 0, 1, 1, 0. And then afterwards, we are going to put our object A, B, C, D. So that gives us 3, 2. B is 5, 2. C is 5, negative 1. And D is 1, negative 1. And when we do this multiplication, we should get A prime, B prime, C prime, D prime. So pause the video and see if you could do this multiplication, and hopefully you could get the image. Right, so hopefully you got through. A prime we got to be 2, 3. B prime we got to be 2, 5. For C prime we got negative 1, 5. And for D prime, we got negative 1 and positive 1. So let's draw this little sketch on our diagram here and see what it looks like. We have A prime being 2 on the x and 3 on the y, which puts it about here, A prime. We have our B prime to be 2 on the x and 5 on the y, so that puts it about here, B prime. We have our C prime to be negative 1 on the x and 5 on the y, so that puts it about here at C prime. And our D prime is negative 1 on the x and 1 on the y, and that puts D prime around here. So if we draw this diagram here now, we could see that this image is a reflection of our object in the line y is equal to x. So again, please note that you have to put your transformation before the object in the multiplication, and you also have to make a note of this special 2 by 2 matrix that represents a reflection in the line y is equal to x. Now let's check out a reflection in the line y is equal to negative x, and we see here that we have a special transformation for that. The transformation, the 2 by 2 matrix here, of m of y is equal to negative x is given by 0, negative 1, negative 1, 0, right? So if we have the trapezium PQRS as shown in this little sketch here, and we have the points of the trapezium, we have to find the reflection of this object, which will be P prime, Q prime, R prime, and S prime, in the line y is equal to negative x. So first, we will put our transformation, the m of y is equal to negative x, and that transformation is 0, negative 1, negative 1, 0. And we're going to multiply that by our object PQRS. So PQRS, the trapezium, P is negative 6, 2. Q is negative 3, 2. R is negative 1, negative 1. And S is negative 6, negative 1. And hopefully, if we do this multiplication correctly, we should get P prime, Q prime, R prime, and S prime. So pause the video, do this multiplication, and see if you get the image. Right, so the image that we got when we did the multiplication correctly was negative 2, 6, negative 2, 3, R prime, we get as 1, 1, and S prime as 1, 6. So let's look and see if it looks like a reflection. So we'll plot the point P prime, negative 2 on the x and 6 on the y, all the way up here. So that is our P prime. Q prime is negative 2 on the x and 3 on the y, so that's going to be about here, Q prime. R prime is 1 on the x, 1 on the y, so that puts us about here, R prime. And S prime is 1 on the x and 6 on the y, so that brings us here with S prime. And when we connect the dots and we draw this image, we could see that the image looks like a reflection of the object if it were reflected in the mirror line y is equal to negative x. So this y is equal to negative x acts like the mirror, and we could see here that we could find a reflection of the object using this transformation here that we need to know by heart. Right, so moving on to with reflections, this is reflections number 5, a reflection in the origin. So let's see what that looks like. A reflection in the origin is given by the 2 by 2 matrix transformation MO. That O is for origin, and it is negative 1, 0, 0, negative 1. As I say, you have to know these things by heart, so please make a list of all of these different transformations. Right. Now we have a parallelogram here, KLMN, and these are the points, and we need to find the image as it is reflected in the origin. So since it's a reflection in the origin, we will put the transformation for the origin first, a reflection in the origin, negative 1, 0, 0, negative 1. And then afterwards, we'll put our points K, L, M, N, and that will give us the point 2, 3, the point 6, 3, the point 4, 1, and the point 0, 1. Right, now take a minute and do this matrix multiplication. The practice is good. And see if you arrive at K prime, L prime, M prime, N prime, which is our reflection in the origin. So when we work out our reflection in the origin, we get negative 2, 3. Oh no, negative 2, negative 3. For L prime, we get negative 6, negative 3. For M prime, we get negative 4, negative 1. And for N prime, we get 0, negative 1. So let's plot this and see what it looks like here. A reflection in the origin. So this is the origin here. Let's try K prime. That's negative 2 on the X, negative 3 on the Y. Puts it about here. So this is our K prime. The L prime, negative 6 on the X, negative 3 on the Y. So over here, that gives us our L prime. M prime, negative 4 on the X, negative 1 on the Y. So that puts it about here. And that is our M prime. And then N prime is 0 on the X and then negative 1 on the Y. So N prime over here. And when we draw this image, just a little sketch of the image, we could see what a reflection in the origin looks like. Because if we take a look at it, we could see that this K is reflected through the origin to this K. This L is reflected through the origin to this L. This M is reflected through the origin to this M. And this N is reflected through the origin to this N. So we could see here that all of the points are reflected within the origin, that single point here. Also, please make note that the object, the transformation, comes first in the multiplication and then the object. Now, moving on with transformations, we have what is called the enlargement. Now, an enlargement that is centered at the origin O, so this is the origin O, right, is given by this 2 by 2 matrix. And notice for enlargements, we aren't calling it M, we call it E, right? So E is the matrix for an enlargement. And the enlargement, what it does is it takes an object and it will make it bigger or smaller depending on this scale factor K. Right, so let's try this example here. And for this example, we could see that we have a parallelogram shown here, and that parallelogram is ABCD. And we want to find the image of ABCD at an enlargement scale factor of 2 centered at the origin. So if the enlargement scale factor is 2, then that means K will be 2. So we will put our enlargement matrix as 2, 0, 0, 2. And then we will multiply it by our object, A, B, C, D. And our object, the point A is 2, 1. The point B is 3, 3. The point C is 6, 3. And the point D is 5, 1. So let's do that multiplication and see if we can come up with A prime, B prime, C prime, D prime. So hopefully you paused the video and Now let's find out what A prime, B prime, C prime is if you did the multiplication correctly. A prime ends up being 4, 2. B prime is 6, 6. D prime gives us 12, 6. Sorry, that's C prime. And D prime is actually 10, 2. So let's plot this on our graph here and see what it looks like. We have A prime being 4 on the X and 2 on the Y. So that's this point here. We have our B prime being 6 on the X and 6 on the Y. 2, 4, 6. So that's this point here. So this is the point A prime. This is the point B prime. We could kind of see what's happening here. The point C prime is 12, 6. So that's C prime. And D prime is 10, 2. So that's about there. D prime. So if we look at it, we could see here that our image is definitely larger than the object, right? We have the image here that's been enlarged by a factor of 2, so this image is twice as large as the object. And the enlargement is also happening with the center point 0, 0, the center point at the origin. So from the origin, we could see that the object A maps to the image A prime. From the origin, we could see that the object B maps to the image B prime. From the origin, we could see that the object C maps to the image C prime, as well as the object D maps to the image D prime. So we could see all of these things playing out. Now let's look at part 2 here, and part 2 is to find the image of ABCD with a scale factor of 1/2. So let's see how that works. We are going to have to put our E as being 1/2, 0, 0, 1/2, and multiply that by our object ABCD, which is 2, 1, 3, 3, 6, 3, 5, 1. And we will find, and let's just call it A double prime, B double prime, C double prime, D double prime, so we don't get it mixed up with the other image. Now please pause the video and do this matrix multiplication and see if you get the answer. So when we work this out, and we could actually have this in decimal places when we work it, so we get 1 and 1/2 for A double prime. For B double prime, we have 1 1/2, let's just call it 1.5, as well as 1.5 for B double prime. For C double prime, we have 3 and 1.5. And for D double prime, we have 2.5 and 0.5. So let's check and see what this looks like. So we have A double prime to be 1 on the X and about 1/2 on the Y. So 1/2 puts us at about here. Our B double prime, the B double prime will give us 1 1/2. So 1 1/2 here puts us here, and then 1 1/2 on the X, on the Y puts us at about here. And I want you to notice something. I want you to notice how small this is going to look. For C double prime, I have 3 on the X and 1.5 over here. So apparently this image is not an enlargement. The image got smaller. Yeah. We could see here that the D double prime is 2.5. So that puts us at about here, and then a half, it puts us about here. And this here is our new smaller image, A double prime, B double prime, C double prime, D double prime. So what do we notice here? That when K is greater than 1, the image gets larger. But when K is less than 1, in this case K was a half, the image gets smaller. So this is something to notice. Another thing to keep in mind is that if K was negative, then the image would actually flip and be a reflection in the origin. So you'd end up having the enlargement taking place on this side of that center of enlargement. Yes? So these are a couple of things to note. It's actually a pretty easy concept. So just to recap, when we are talking about an enlargement that is centered at the origin, so the center of the enlargement is the origin. It is given by this matrix here, E, which is K00, K, where K is the scale factor of the enlargement. We could see here that when K was greater than 1, so in this case K was 2, the image got larger. And when K is less than 1, in this case K is a half, the image actually got smaller. Yeah. Now moving on to this, we have the enlargement, but where the center of the enlargement is not the origin, the center of the enlargement is some point A, B. Yeah? So an enlargement centered at the point C, which is coordinates AB, is found by multiplying the object by the scale factor matrix, which is what you normally did, right? And translating the image using some vector t. So how do we find an enlargement where the center of the enlargement is some point AB? Well, we take the enlargement, just as usual, the enlargement matrix with the scale factor, and multiply it by the object. And that will actually give us an enlargement from the origin. But then we have to add some translation t in order to shift it off the origin. Right? Now let's take a look at a simple example here. So in this example here we have P, Q, and R, a triangle, as we could see in our little sketch. And they say that it undergoes an enlargement that is represented by this equation. Now, I want you to just notice what's going on with this equation here. And let's just take a look at the general equation. First, we have the enlargement matrix that is being multiplied by the object, right? So this here is the object. Whatever matrix, how much ever points it is, we take the enlargement matrix, multiply it by the object, and then we add it to some translation, and that gives us the image. So what are they saying here? They're saying here that we have the scale factor enlargement matrix multiplied by the object plus this translation that they gave us. And that will give us our image. So let's see if we could actually do this question here. First, we have the enlargement matrix with the scale factor of 3, 3, 0, 0, 3. And then we have to multiply that by our object. So we have E here, and we have to multiply it by the object PQR. So the object PQR gives us negative 5, 2 for P. Q is negative 1, 4. And R is negative 2, 1. And we are going to add that to some translation that they gave us there, the translation T being 5, negative 2. And that should give us our image. So the first thing I would do is do the multiplication, then add the translation, and see what the image ends up being. So pause the video and take a few minutes and do it, and just press play for the answer. Right, so hopefully when you did the multiplication of the enlargement matrix with the object, you would have gotten this matrix over here, negative 15, 6, negative 3, 0, and negative 6, 3. And now we just add the translation that they gave us, and that should give us our image P prime, Q prime, R prime. And that image ends up being negative 10, 4. Q prime ends up giving us 2, 10. And R prime ends up giving us negative 1, 1. So let's try to draw this and see where this object ends up. So P prime is negative 10 on the X and 4 on the Y, so that's P prime. Q prime is 2 on the X and 10 on the Y, so all the way up here. Wow, this thing is going to be huge. And then R prime is negative 1 and 1, so that's about here. So, and that will give us our R prime. And if we was to draw this image here, we would see that it is indeed an enlargement. And this enlargement is not in the origin. It's absolutely not in the origin, right? So what we have to do is we have to find, well, what is the center of enlargement? And the next question asked us to find the center of enlargement. So what is the center of enlargement if, in this case, the center of enlargement is not 0? Then what will it be? So let's see if we could find what the center of enlargement is. And in order to find the center of enlargement, we just need to remember one rule. And the rule is that the center of enlargement always maps onto itself. The center of enlargement always maps onto itself. So, if I was to take this very same equation that the question gave me, I have the enlargement with a scale factor of 3, 3, 0, 0, 3. And now I have my object, and for my object, I am going to put the center of enlargement being A, B. So what we are doing is we actually taking this center of enlargement, this unknown point AB, and we're going to put it through this translation, this transformation. So I have the enlargement plus the center of enlargement, the enlargement multiplied by the center of enlargement, plus this translation that they gave us, 5, negative 2. And what we are saying here is the center of enlargement always maps on to itself. So when you take this center of enlargement, this point, and you run it through the transformation, you are supposed to get no change. It is supposed to remain one single point. So if you take a point and you run it through this program, you run it through this equation, this transformation, and you get back the same point, then that point is the center of enlargement. It'll always map on to itself. So what can we do with this? Well, we could form two equations and find for A and B. So the first thing we would have to do is multiply this enlargement matrix by our center of enlargement. So what would we have? We would have 3A plus 0B, which is 0, right? And then we would have 0A plus 3B. Right? So when we multiply this, these two vectors, this is what we get, these two matrices, and we're going to add that to our translation 5, -2, and that should give us back AB, which is our center point. So we could simplify this by saying 3A, and then this bottom would be 3B, plus the translation 5, -2, and that is supposed to give us AB. So we could see here that we have two different equations. We have the first equation, 3A plus 5, the x values that we are adding in the matrices, and that gives us A. And then we have the other equation, 3B minus 2, and that gives us B. So how we could do this? We could just simply solve these equations. If we bring this A across, it'll become -A. So I'll have 2A is equal to -5. Therefore, A is equal to -5 on 2. And then I have this point B. If I bring the B across, it'll be -B. So I'll end up with 2B is equal to 2, therefore B is equal to 1. So our center point C is 2, -2.5, and 1. So let's see if we look on this diagram here. -2.5 puts us at about here, -2.5. And then we have the value 1. So this here is our center, and we could see here that from the center, the R maps on to the R, the Q maps on to the Q, and the P maps on to the P. So just to recap, when we are talking about the center of enlargement, where the point is not the origin, the point is some point AB, then we actually have to use a matrix equation where we have the actual normal story of multiplying the enlargement matrix by the object, but then we have to add some translation that is usually given, and that will give us our image. Now we take a glide reflection. And what is a glide reflection? A glide reflection is simply a combination of a translation and a reflection in any order. So let's take a look at this example here. The glide reflection G. Now you notice for this transformation we use G to stand for glide reflection. It consists of this translation T being 3, 3, followed by a reflection in the line y is equal to x. So I have this translation, this glide reflection G, and it consists of a translation first, followed by a reflection in the line y is equal to x. So the first thing I have to do is I have to find the translation. Now, one thing to remember about this combination is that you don't have to do the translation first. You could do the reflection first and then the translation, and you will actually get the same answer. But since the question says here that the reflection consists of the translation first, followed by a reflection in the y-axis, sorry, not in the line y is equal to x right here, then what we will do is we will do the translation first. So I have my object, and remember, for our translation I could put my object ABC in a matrix, and that will be 2, 1, 4, 2, and 4, 1, and I can add it to my translation 3, 3, T, and that will give me A prime, B prime, C prime, which is 2 plus 3 is 5, 4 and 3 is 7 and 7, 1 plus 3 is 4, 5 and 4. So this gives us our reflection, our image when we translate or put the object under the translation 3, 3. So now that we have done the translation first, now we have to follow that by a reflection in the line y is equal to x. So remember, we have to make note and we have to remember that a reflection in the line, a reflection M in the line y is equal to x is given by this matrix 0, 1, 1, 0, right? We should commit that to memory. And then we multiply that by our A prime, B prime, C prime, right? So the A prime, B prime, C prime is 5, 7, 7, 4, 5, 4. And this should give us our final image, double prime, B double prime, C double prime. Now, take a minute, do this matrix multiplication, and then press play for the answer. So, hopefully you did this, and you should have gotten 4, 5, 5, 7, and 4, 7. So you could see that it just kind of flipped it. And so what we did here was we have a glide reflection G, right? So this glide reflection G is equal to the translation 3, 3, and after you translate the object, then you reflect that in the line y is equal to x. So first we took the object ABC and we did the translation to find that image, and then we reflected that image in the line y is equal to x to give us the final image. So let's see how that looks on the graph. Right, so on the graph here we have our little sketch, and we could see that when we translated the image ABC, we got A prime to be 5 on the x and 4 on the y. So that puts us about there. That's our A prime. B prime was 7 on the x and 5 on the y. And C prime was 7 on the x and 4 on the y. C prime. So that was our translation here. So first we took the object and we translated it under the translation 3, 3. And now we are going to reflect it in the line y is equal to x, right? So when we did this reflection here, remember the reflection matrix came first and then the object that we are translating or reflecting. So A double prime, and I'll do this in red, ends up being 4, 5. So that's about here. B double prime was 5, 7. Gives us about here. And then C double prime was 4, 7. That puts us at about here. So this is A double prime, B double prime, C double prime. And we could see here that this is a reflection in this line. It's very crudely drawn, just a sketch really. But we could see that 1 is a reflection in the line y is equal to x. And really and truly, it's this object that ends up over here based on all of this working. Yeah, so this is the object, the original object, ABC. And first we did a translation. And then after the translation, whatever that answer was, we took that and we reflected it in the line y is equal to x. So just remember, with a glide reflection, we can do a combination of a translation and a reflection in any order, right? So as an exercise, you could try this same question, but do the reflection first and then do the translation and see if you come up with the same answer. Now let's take a look at rotations. Now a rotation is simply if you were to just take an object and you were to rotate it around a central point in a circular motion. So of course, because we're dealing with circles, we're going to be dealing with angles, and we have the angle theta. And what we have to note is that about a single point called the center of rotation, angles measured in an anti-clockwise direction are considered positive. And we could see that here. If we are measuring from the angle from P to P prime, this angle here, we are going in an anti-clockwise direction, so that angle will be positive theta. Whilst angles measured in an anti-clockwise direction, so if we were going in this way, we would have to consider this as negative theta. Now, we have a lot to remember here. Generally, for any anti-clockwise rotation, r theta, the rotation matrix for theta, is this matrix here. Cos theta minus sine theta, cos theta. Now, essentially, we could use this to solve for any anti-clockwise rotation, at all. However, there are some simpler simpler matrices that we could commit to memory. For example, an anti-clockwise rotation of 90 degrees. That would mean that I would have the cos of 90, the minus sine of 90, the sine of 90, and the cos of 90. And that just works out to be this matrix here, 0, negative 1, 1, 0. So thankfully, an anti-clockwise rotation of 90 degrees gives us a simple matrix to work with. Similarly, an anti-clockwise rotation of 180 degrees gives us this gives us this very simple matrix to work with. So the R of 180, or the rotation of 180 degrees, is negative 1, 0, 0, negative 1. And an anti-clockwise rotation of 270 degrees gives us this simple matrix here. R of 270 is 0, 1, negative 1, 0. Now all of these here, all of these matrices were just basically derived from this one. So they put the 90 degrees where theta is and they got this. They put the 180 where theta is and they got this. You put your 270 where theta is and you get this. Now we do have, now I want you to keep in mind that this is the matrix for if we have an anti-clockwise motion where theta is positive. Right? We have a different matrix here for when we have theta to be negative, that is a clockwise rotation, and that is given by this matrix, cos theta, sine theta, negative sine theta, cos theta for any value of theta. Right? So we do have two different matrices for clockwise and anti-clockwise motions. Let's just check an example to see how these guys work. So we have this object, the triangle PQR, and it's given by these points. P is 2, 3, Q is 5, 0, and R is 4, 3. And it's under a couple of rotations here. So we have this object PQR, and we want to know, number one, find the image under a clockwise rotation of 150 degrees, and number two, find the image under an anti-clockwise rotation of 135 degrees. So let's check these two questions. Let's try number one first. I'm going to remember my matrix for the first one is a clockwise rotation of 150 degrees. So my matrix for a clockwise rotation, that is R negative theta, is equal to cos theta, sine theta, negative sine theta, cos theta. So what I'm going to do is simply just take my transformation rotation matrix, R negative theta, and I'm going to multiply it by my object P, Q, and R, and hopefully that should give me my image P prime, Q prime, R prime. So let's check it out. Our transformation rotation matrix would be the cos of 150, the sine of 150, the negative sine of 150, and the cos of 150. And we're going to take these and multiply it by our object. So our object being P 2, 3, Q 5, 0, and R, which is 4, 3. So first, let's just work out what is all of this cos sine business. So this matrix here, the cos of 150 ends up being minus 0.86. The sine of 150 ends up being 0.5. Minus sine of 150 ends up being minus 0.5. And the cos of 150 again being 0.86. So we take that, we multiply it by our object 2, 3, 5, 0, 4, 3. And this should give us our image P prime, Q prime, R prime, which will be, please pause the video, see if you could do this calculation, and then just press play for the answer. So P prime, Q prime, R prime should be, P prime gives us a negative 0.2, and negative 3.6. Our Q prime gives us negative 4.3 and negative 2.5. And our R prime gives us negative 5.0 and negative 0.6. So this is our image here. And just to recap, what we did was we took our rotational matrix for a clockwise rotation, which is this matrix here, and we multiplied that by our object at 150 degrees. So we worked out what the matrix was for 150 degrees, multiplied that by our object, and got our image nice and easy. Now let's try number 2. Number 2, we are dealing with an anti-clockwise rotation of 135 degrees. So anti-clockwise being our theta, and the matrix for that gives us cos theta, negative sine theta, sine theta, cos theta. So it's the same story essentially. We are going to take our rotational matrix and we're going to multiply it by our object. So the rotational matrix will be the cos of 135, negative sine of 135, the sine of 135, and the cos of 135. And we are going to multiply that by our object P, Q, R. And the object is 235,043. And let's see what we get. So pause the video and see if you could do this multiplication. Remember, the first thing is you would need to simplify this, find the cos of 135 and simplify this rotational matrix, and then do the multiplication. So pause the video and try that out. Right, so hopefully when you did your calculations, you would have been able to get negative 0.707, negative 0.707, 0.707, and negative 0.707 to be your rotational matrix. And when you multiply that by your object, you would have gotten this image, and hopefully you got the image to be P prime is negative 3.5 and negative 0.7. Q prime is negative 3.5 and 5.5. And R prime is negative 0.7 and 4.9. So that basically completes the chapter for transformations. As you can see, transformations is quite a huge topic here, and yeah, so you could check out some of the questions in the classroom and feel free to call or message if you have any questions of your own. So I hope that this video was helpful to you all, and please have a good day and good luck.